Okay, so we're talking about absolute value functions and graphs. I have 4 boxes, but I think I actually have 5. So here we go. So the first thing you should know is that the absolute value graph is this V looking thing right here, right? So looks like a V. And the reason is because like the absolute value of 3, of course, is just 3. So the point 3 comma 3 should definitely be on the graph, right? But it's also true that, the absolute value of -3 is also 3. So if I go -3, then 3 is also on the graph. And that's true for all of these. So you get this, what I call the V graph here. Okay, pretty straightforward. Okay, so you should know that's what the graph looks like. It's pretty, you got that. Okay. Let's talk about this part now. This is an important aspect here. So just like in our transformations, I want you to be able to look at the equation and know precisely where it's going to go and what it's going to do. So for example, what I mean by that is if I'm taking the absolute value function and I am subtracting 4, you should know that this is going to move the entire graph down 4 units. And I think you already know that because we talked about it in the last section. So what's this one going to do? If your -4 is on the inside of your function, this is going to go to the right 4 units because it's on the inside. If we have a negative sign on the outside, we're going to get a reflection, and it's going to be over the x-axis. Okay, if we have a negative that's on the inside, we're going to get another reflection, but it's going to be over the y-axis. Okay, +3, you should know that this is going to move it up 3 because we're adding a number to our function on the outside. So up 3, this is how we would describe it. On the inside of our function here, this is going to be to the left 5 units. Now here we go. If we have a number being multiplied on the outside of our function that's greater than 1, since 3 is greater than 1, we're going to get a vertical stretch. All right, and if we have a number on the outside of our function that's in between 0 and 1, so we'll call our number a, for example, less than a, less than 1. If our number is in between that, we're going to get a vertical shrink. Okay, so hopefully that's a review for you, but if not, we're going to explore this right now. So I'm going to talk a little bit about this general form, and then we're going to explore it on fluid math together, okay? So the a out in front of our function value, this is going to give us vertical stretches, and those can be either skinny or fat. We'll talk about that in just a second. Okay, the vertex of our absolute value graph is always going to be h comma k. So notice that this says a -h on the inside, and it becomes a positive h over here. And this is a positive k over here, and this is a positive k here. So what you want to remember is that the sign on the inside is going to change signs, but the one on the outside, the k, does not. This one over here does not change at all. Okay? So let's explore some of these examples together on fluid math together. And here we go. So here's the general form one. And I have just y equals a, x minus h, and then plus k in absolute value. The vertex is going to be h comma k. That means like the lowest point or the highest point of this, okay? So I have 3 variables. So I have a, I have h, and I have k. So first let's talk about this a. What's that going to do if a is bigger than 1? Well, if you watch, right, if I move this to the graph, look what happened to the graph. It got a lot skinnier, and I'll use non-discrete values. So it's a little bit more fluid. So look how skinny this thing gets, right, if my a is greater than 1. So I'll move it back to 1 now. And then look what happens then if my a is between 0 and 1. So I'll go non-discrete values, and if it's between 0 and 1, check it out, it's going to get wider. Okay, so it looks like I've flattened out. That's a vertical stretch. So look, we have a 0.57 that's between 0 and 1, and we have a wide graph here. So I'll move this back to 1, just so you can see. Now let's move this h value. Okay, right now h is set to 0. Look what happens to the graph when I move it, and I'll use when I go to the right. Notice that the graph also moves to the right because the h value is 2.67, but it's really negative when I plug it into my function here, right? Did you see that? So if my h value is a negative, for example, notice that the negative of a negative would be a positive 1.135, and it would move to the left here for that, right? So kind of confusing because of the way it is written here, but this is the general form for it. Just know that the vertex is always at h comma k. So I'll move this back to discrete values, and I'll move it back to 0. And let's talk about the k value. The k is on the outside here, right? This is going to move it up or down. So if I move it, if k is 3, I go up 3. If k is -2, I go down 2. So the k moves it up and down, and the h value moves it left and right. So you can see over there in the video what's going on, okay? Hopefully that makes some sense to you. Let's go back over here. So let's do this example here. Okay, how would I graph this function? I have 2 times an x minus 1, then a plus 3. Well, I can always start with the original function, which of course is just y equals absolute value of x. So I'll have this point, this point, this point, this point, and then I can draw my v-graph, and very, very simple. And we should all have that part down. Okay, that's the first thing I can do. The second thing I can do, I'll choose a different color here for you, is I can do the absolute value of 2 times x. Well, because that 2 is greater than 1, it's going to make it skinnier. So instead of going over 1 and up 1, I'm going to go over 1 and up 2. That's how I make my graph skinnier by a factor of 2. So I have this skinny graph here. So notice my purple one is inside the black one there. Alright, fair enough. Moving right along. So the third thing I can do, using transformations, I can have 2 and then an x minus 1. If I have a minus 1 on the inside, that's going to move my graph 1 unit to the right. So all my purple dots move to the right 1 unit, and that goes there. And so now I have this green graph that looks like this. And then last but not least, of course, I need to take my graph and complete it. I'll have an x minus 1 and then finally a plus 3. So the last step is to take my green dot, move it up 3 units. 1, 2, 3. There's my vertex. Over 1, 1, 2, 3, over 1, 1, 2, 3. So notice that in this particular case, the vertex is at the point 1, comma 3, which is what it says right there. 1, comma 3. There's my vertex. And just to check we're all good with this, I've got it all set up first here. And if I plug it into here, you can see there it is right there. Our vertex is indeed at 1, comma 3. Okay? Last little example here. Actually, it's on Fluid Math for it, sorry. It would be this graph here. So let's say I have this red graph over here, right? I have this red graph, and I need to come up with the equation that's going to make this red graph true. So I'm going to start with the green graph over here, right? And so the first thing I want to do is I need to move my graph 3 units to the left, okay? So because I have a negative h value here, I'm actually just going to move this thing 3 units to the left so we can all see it. I'll use discrete values. Okay, boom. Now the blue graph that you see is just the absolute value function as it is, the parent graph, okay? Now I need to reflect this thing, so I need to go A needs to be a -1, okay? So good, now I have a reflection, all right? But now I need to move it down 2 units. So I'm going to move the K down 2 units. All right, it's looking good so far, right? And then I need to actually make my green graph a little fatter. So that means that my A value has to be between -0 and 1. So I'll use non-discrete values now, and I'll try and get this to match up exactly. And it's pretty close. You can see that looks like it wants to be a half. If I can make it a half, let's see how close I can get to this thing. Well, it's almost there. My green graph. Almost, right? Oh, there it is right there. I found it. Sweet. I got so excited. Okay, so it looks like the equation, so the A value is -1/2. So I'm going to have a -1/2 absolute value. I'm going to have an x. This is going to be +3 because I went 3 units to the left. And then finally, I'm going to go down 2. So that would be the equation that matches it up perfectly. Hope this helps you guys.